I'm Anil Kumar, and here is a challenge area of triangle question. The question here is, in triangle PQR, the points L, M and N are on QR, PR and PQ respectively. MN is parallel to QR, LN is parallel to PR and PN and Q equals to, the ratio of PN and Q is equals to 1:4. Calculate the ratio of area of the quadrilateral MNLR to the triangle PQR. So I'd like you to read the question once again, copy it, solve it, and then look into my suggestion. There are too many things going on in this question. But while you read this time, look at the diagram. It will help you to understand. So we are given a triangle PQR. There are points N, M, and L. Ratio of PN and NQ is 1:4. So in short, that is what we read. Just read it once again. In triangle PQR, that means the big triangle, L, M, and R on QR. So QR we have L, and PR we have M, that's perfect, and PQ we have N, right. MN is parallel to QR, so that side is parallel to QR, okay, and LN is parallel to PR. So let me draw 3 dots here. Okay, so these two sides are also parallel. The ratio and PR and MN, the ratio of PN, this ratio, PN to NQ is 1:4. What you need to calculate is calculate the ratio of area of quadrilateral MNLR, the big quadrilateral shown here, and the small triangle or big triangle PQR. This is what you have to find out. Okay, let me write down. So we want a ratio of quadrilateral, which is MNLR, to ratio of the triangle, which is PQR. I mean PQR, right? The big triangle. Okay, so let me shade this rectangle quadrilateral also. So that's the quadrilateral whose area we are interested in finding. Okay, and the area of the whole triangle. That is the question. So now you can pause the video, answer the question, and then look into my suggestion. Now I'll solve like this. We know PQ, it is in the ratio of 1:4. So whenever we know ratios, I actually try to find what is the total number. So PQ total is 4 plus 1. So 4 plus 1 is equals to 5. It's just 4, right? So PQ totally is 5, correct? And the ratio is 1:4. That is how I see it. Second, I know that MN is parallel to QR. So we have two similar triangles. So we have PNM, this small triangle, is similar to big triangle PQR. PQR, perfect, right? The small triangle PNM is similar to big triangle PQR, correct? Since the sides are in the ratio of 1:5, see, big triangle is 5. Do you get the idea, right? So the ratio of PN to PQ, big triangle, PQ will be what? 1:5. Do you understand? So the ratio of the sides for small triangle to big triangle is 1:5. In that case, what is the ratio of their area? So area of triangle PNM over area of triangle, big triangle PQR, is what? Square times, right? It is square of PN over PQ whole square, right? Which is 1/5 square. So I could write this as 1/25. You get my point. So the ratio is 1/25, correct? So that is what we have found so far. What we need to find is ratio of triangle PQR to rectangle, quadrilateral I should say. It's a parallelogram here. So it's a parallelogram. These two sides are parallel, correct? And these two sides are also parallel, right? We need to find the ratio of that to the whole triangle. Now what we will do is, we will assume, since we know this is 1:25, right? Area of triangle PNM is 1. So we say let area of triangle PNM be 1 unit square. In that case, area of triangle PQR equals to 25. That's the meaning of this, right? 1:25. Is that okay? So that is how we consider. So what we are saying is, let this area be 1. Correct. In that area, if this area is 1, the total area is how much? 25. That means where is the rest 24? 24 is equally distributed between 3 parts. Correct? Now, you can prove that these 3 are equilateral. These 3 are congruent triangles. You can prove that, since we know that these 2 sides are parallel, these 2 sides are parallel, right? So in that case, you can prove that these 3 triangles are equal, correct? Now, at least you can prove this and this is equal, right? And then you can prove that one also. So I'm leaving that proof for you, okay, that these are congruent triangles. So what we have here is that a triangle NQL is congruent to triangle NLM, which is also congruent to triangle MLR. That means the area is divided equally, right? So that means rest of the area is divided equally, right? So that means if area is 1 unit here, then the area in these 3 triangles is 24 divided by 3, which is 8 units, right? So this is 8, and this is 8. Do you get my point? So like this, we can look into this question, and then you know the solution now, right? So you can now say that the area of parallelogram MNLR is how much? 8 plus 8, 16 unit square, perfect, over area of triangle PQR, which is how much? 8 plus 8 plus 8 plus 1, okay, 25 unit square. Do you get the idea? So that is how we can find the ratio of these 2 things, right? So we get our answer as 16/25 as the answer for this particular question. I hope that helps, right? Which is actually, if you look at it, it is 4/5 whole square, correct? So that is how we can actually solve this particular question. It's very interesting, and for you as an exercise, you need to show that these should be 8 and 8 if that is 1. Okay, so that will be an exercise for you to do. I hope that helps. Thank you and all the best.